Hi everyone, and with this video I want to take you through the time value of money, and I'm not going to get into some of the heavy mechanics on the formula for a present value of an annuity or anything like that. We're going to use some tools in Excel, and basically what I want to do with this video is explain the concept of an amortization schedule. In other words, how a debt is amortized over time as you make payments. So let's get started and set up a timeline. And we're in this timeline, all of us can relate to the buying of a car, right? So you go out and you purchase a car, and the present value, what it's worth today, is basically in this scenario, it's the purchase price. It's your net purchase price minus any down payment you made. And then obviously they're going to say, well, how long do you want to, as a time period, to pay it off? And so we're going to make an assumption in this illustration that we're going to use 60 periods, 60 payments of an amount, $727.67 each month, and 67 cents, excuse me, and then the total payments that you would make would be just 60 times this monthly payment, and that's how I get the $43,660. Well, what happens at the end of the 5 years, or 60 months, is you'll end up with a title, and so then they'll send that to you in the mail, and you then own the car. Now, during this timeline, all during these 60 months, you're making the payments. You own part of the car, if you will, but you don't really have the title. And if you did trade it in or you sold it, what's the first thing you have to do? Well, you have to pay off the unamortized balance of that loan. So now you may have some questions. You may say, okay, what is that unamortized balance? But before we get to that, let's think about or look at everything, all the variables that come into play here. First of all, I didn't tell you what interest rate you are being charged. I just set it up and said you're going to have 60 payments, and this is going to be the amount per month. And so you really don't know if you're getting a good interest rate or not. All we do know is there's some interest rate being charged because the present value of 40,000, and then if I look at my final amount, if I aggregate all of my payments together, I now would have paid $43,660. So what is the difference? Well, that $3,660.20 is interest, obviously. Now, what if you can only afford $600 a month? Well, obviously you could get a different car that's cheaper. But the other thing you may be able to do is stretch out this period of your repayment. Instead of 60 months, maybe you want to stretch it out to 72 months. Add a whole year to that, and you'll be paying on, instead of 5 years, it'd be 6 years. But it would indeed bring down your monthly payment. And obviously, you could shop around for a lower interest rate. Not all banks charge the same rate. Maybe you go to a credit union that you're a member of, and they offer a better rate. Maybe the finance company that's behind this brand of automobile, this happens to be a Chevy Volt, and for a period of time, the Volt was being sold with 0% interest. So anybody that doesn't sign up for that payment plan is really crazy, because 0% interest is the best you're going to get ever. So, but you may be able to negotiate a lower rate with a different bank, and obviously that would come into play in this calculation of determining what that payment amount is. And then if you inherit some money, if we all should be so lucky, inherit some money, or some of it fall out of the sky, you find it on the street or whatever, and you say, I want to pay off the loan early. How do you determine how much you owe, how much you have to pay at that moment, in order then to totally own this car? Because that loan, remember, over time, that loan is being amortized, and so there will be some amount. Maybe you're at this point on the timeline, at this point on the timeline, and so forth. So the tools we have through Excel can make that very simple to determine. So let's get moving and talk about a few things by way of background. One thing as a finance student you should know is about the Truth in Lending Act of 1968. That was what you call just not a watershed, but a real turning point in terms of the way things are done in the banking industry. Now, what that act does is it requires that the finance charge, the total dollar amount being charged to the customer for the credit that they're being extended. That's a requirement of Truth in Lending Act. It also says that you must always disclose interest on an annual rate, the APR. You've probably heard that in news reports or just in common things maybe on a commercial from a bank. The APR, the annual percentage rate, that is critical, and you must disclose that. As far as this is the interest being charged to the customer, it's quoted on an annual basis, and it's in terms of a rate, so it means it's a percentage, and you'll use that rate, or we'll show how to use that rate when we're talking about the number of periodic payments, which is also another way of saying the number of compounding periods that are involved in this transaction. The amount financed, remember back on the timeline illustration, that's the value of that car, whatever it is you're buying it for. So how much are you actually borrowing in this transaction? Another thing you have to do is you have to tally up the total number of payments. And so back in our illustration, it was that monthly payment times 60 months, and so that was like $43,000 and change. So you must disclose what that aggregate amount is. And then, of course, the total sales price. This is the cost that you're financing, which would include the down payment and the periodic payments. So that's the grand total. And the Truth in Lending Act was, mainly targeted for consumer-type loans, car loans, or maybe a personal loan that doesn't have any collateral to it. But it really set a common basis for disclosure, and it was just a really important piece of legislation for the consumer. Now, when we talk about a loan, an installment loan, the word installment just means a periodic payment. There's going to be, it's over time, and so you'll have this periodic payment coming into play. Now, there are four critical elements. You need to focus on this. The first is going to be the principal, which is the amount borrowed. Now, another piece of that puzzle is going to be the term of this loan. How long are you going to take to pay it back? Another one is the rate. The rate is going to then determine, the rate coupled with these other components are going to determine how much that payment is going to be. And remember, this rate is always, always, always disclosed on an annual basis, annual percentage rate. Now we will determine, you'll see this later in the calculations, we'll determine what the rate is per period, and you can have daily compounding, you can have weekly, monthly, quarterly, semi-annual, annual, and that's so compounding period, you have to know that. And now I would ask you, what is the typical compounding period in a car loan? Well, hopefully your answer is it's a monthly compounding period because you're making monthly payments. And then, of course, we just mentioned payment. That is the last piece of this puzzle, is that periodic payment that you have to make, and that obviously is going to include some amount that's going to pay down some principal. It's going to have some amount to pay down the interest. It's determined based on that interest rate. And so all of these pieces of the puzzle work together for that loan transaction. Now, amortizing the debt. You've heard that term. What does it mean? How do we do it? First, you need to convert that APR to a rate per compounding period. So if we have a monthly payment, you have 12 monthly compounding periods per year. Very obvious. So if your annual rate, and I'm just going to throw this out for illustration, if the annual rate is 10%, and remember Truth in Lending Act means that they must disclose, the lender must disclose the rate on an APR basis, then the rate per month or per compounding period is simply 10% divided by 12 months, and so you get in decimals 0.00833. Which is 0.833% per month, so slightly less than 1% per month. And intuitively, that should be obvious, because if you had, let's say, a rate of 12% and it's a monthly loan, then your monthly or your rate per compounding period would be a very simple arithmetic, and it'd be 1% per period. So, for example, let's say we have monthly payments that are to be made on a loan that is quoted at 3.5% APR. What is the rate per compounding period? So you do the math, it's a monthly rate, and very simply then we would take that 0.035 divided by 12 months, and it is a 0.00292 per compounding period. Just move the decimal place 2 points to the right, and then you'll have your percentage, so almost 0.3% per period. And remember, it's a 3.5% annual rate with monthly compounding periods. Now, during the term of the loan, the principal balance of that debt is earning interest for the lender. You know, that's the lender's like a landlord in the sense that they're getting paid a rent because they did without this money. They're letting you borrow the money, just like a landlord lets you live in the property, and you have to pay them a rent for doing so. Same thing with the lender. They're letting you have that money for whatever the purpose is that you want, and you have to pay them a rent, and they also want their money back, okay, in the end. So what's happening, there are two things getting accomplished as you make that payment. You are paying them for the rent or the interest on the money that you borrowed, and you're also reducing, or this word amortizing. I came from a country background, and we used to, some of the things you could do to pass time would be to whittle. I mean, if you would take a piece of wood, you could whittle away at it, maybe to make a point that you needed to use a sharp stick, or maybe you were trying to carve some kind of figure. That's what whittling is. You're chipping away, you're gradually taking away a piece of that amount with every cut. And so every time you're making a payment, you're amortizing this outstanding balance. Now, what I want to do now is step you through an Excel spreadsheet that shows how easy it is to create an amortization schedule. This is just simply an illustration I threw in for this slide, so let's now look at Excel. As you can see now, we are in an Excel spreadsheet, and I've already set this up for you. Up at the top, you can see where my cursor is, and keep your eyes also on this formula bar, and you can see that we're borrowing $40,000. Now, I pasted in as a bitmap picture the first slide in the PowerPoint presentation so you can refresh your memory on what was going on. Remember, we were buying this car, and we were going to make monthly payments of $727.67, and we were going to go over 60 months. Now, this amortization schedule is to illustrate to you the simple math that's being used to determine how much of the principal is coming down from that original amount of $40,000. And I'm going to use a scroll bar here, and you can see what's happening at the end of 60 months. And that's what this is down here in column A, is there's 60 periods. And what are we at? We're at a zero balance. We're fully amortized. But let's see how that happened. Remember, we had a you don't remember this. We did have we're using a 3.5% rate, but what we had was a payment amount of $727.67. So that payment amount, you can see it's the same amount every month. It's a equal level payment. Now, the fancy term for that in finance is an annuity. In fact, there's a difference between an ordinary annuity and an annuity due. Those are two different things, and the only difference is the timing in which you are making that payment. In an ordinary annuity, think of it's ordinary to go buy a car, and that's done with an ordinary annuity, and so you're making that payment at the end of the compounding period. Think about this. The car dealer is letting you drive that car off the lot, and then you're going to make that payment at the end of the month, at the end of the first month. And so that is an ordinary annuity. So during that month, let's look at what happens when you make that first payment at the end of the first month. What did I have to do? I had to calculate how much that rent, that interest to that lender, how much are they getting? Well, do I just take 3.5%? No. 3.5%, remember, is the annual rate. I have to get a rate per compounding period. So look up here in my formula bar. What am I doing? I'm saying let's start with this unamortized amount, which is $40,000. That is E8 right here, 40,000. And I'm saying I want to multiply that by the interest. B4 right here is my 3.5% rate. And look what I'm doing. I'm dividing it by 12. Why am I doing that? Because these are monthly compounding periods. So what this does is it gives me an annual rate. It's that annual percentage rate per month. Rate divided by 12 in an annual situation. I'm making 12 payments. And so then I get my rate per period. Now you can use your calculator and find out what that rate is. In fact, I think we did it on the earlier slide. And I'm simply rounding this to 2 decimal places. So if I'm making this level payment of $727.67, then a chunk of that, $116.67, is going toward interest to pay the rent to that lender. Now, here's the good thing. Here's what's working in my favor. I am now amortizing I'm whittling away at that prior unamortized balance, and that first payment, $611, is that I'm now owning a piece of the car, if you will, and so now the amount that I owe is $39,389. And look what I did. I simply took the prior unamortized balance and then subtracted the amount that's going toward the principal, this D9, this $611. And I got D9, this 611 was simply the difference between what I paid and my interest. So if I take the 727 minus the 116, I get my 611, and I brought down, I amortized that prior balance. Now look what happened in Excel. I just simply copied these formulas, okay? I can bring it down, and you can see it's the same. The relative references, it's happening up here in the formula bar. I'm just taking that prior unamortized balance, and I'm taking away the amount that went toward principal. Now the other phenomenon to pay attention in this is that even my payment is a level, even amount. Okay, but what's happening? The amount that's going toward interest, and this is good for me as a consumer, each payment is less and less and less and less going toward interest, and I'm earning more and more and more, or getting more and more of that loan balance amortized, and so then it's bringing it down over time. It's amortizing it over time. And now you'll hear people talk about, well, in the early days of your loan, you're not really amortizing much of the principal. Most of it's going toward interest, and you can see that's true here because there's more going to interest of this level payment. There's more going to interest in the early months than there are in the later months. And this is really nice down at the end, where almost my entire payment is going toward amortizing the principal. Even though it's the same amount every month, the bifurcation, the split between interest and principal is getting better as I go through the final months of this loan. So that is the concept of an amortization schedule. It's a simple Excel spreadsheet, and I'd be glad to provide this to you. Now, let's see what happens. What I did here, I'm going to show you a little trick in Excel that you can use in not only an amortization schedule, you can use it in other problems in life, and it's a thing called goal seek, and I'll be using the data tab in Excel, and over here under the what if analysis I have this goal seek. Now you may remember back in the illustration, and let's say now that I can only afford a $600 payment. Okay, I'm going to put in $600 there. Now obviously that is not going to fully amortize my loan because I'm paying a lesser amount. But let's say maybe I can change the term. Right now I'm 60 months, okay, and so maybe I can change the term, and let's see what I can do here. Let me go ahead and let's go down to 72 months. I think we in the prior video had talked about 72 months. And I'll go ahead and I'll copy down the rest of my formula here, and notice even at 72 months I'm still not down to the final paid off amount. But let's just say one of the other variables, we're not going to change the $40,000, that's the price of our car, and let's say we're going to 72 months here, so we've already done that. Now what we've got to do is we have to say the interest is that other piece of the puzzle. Now what I'm going to do is I'm going to show you goal seek. And so let's go with goal seek. Now we're going to set our unamortized balance. We want to get it at the end of 72 months to a value of 0. This is what's called a dialog box when I got there. So I'm going to put it as 0. Now by changing what cell, it has to be a cell that's used in these formulae down here. And let's change our rate. Now as soon as I click OK, that's my last thing in the dialog box, watch what happens. This the rate is going to then cause that amortization balance to go to 0. Now obviously I had to have a better rate, because in order to amortize this at 72 months, I'm fully amortized, I got a lesser rate. So I'd have to shop around in order to get that payment down to $600. I'd have to find a lender that's willing to charge me only 2.57%. Now to review, that was under the data tab. Look at your tabs up here. Under the data tab, under the what if analysis, we used goal seek, and we got this dialog box. And because we already set up our Excel, remember we said set the value. We want to say I want to be fully amortized at a value of 0 by changing what my interest rate is, and then click OK, and we're good to go. And you can see we're fully amortized. We got the payment that we wanted of $600, but we had to shop around to find that rate of 2.57%. Now, I'm going to do another video because what I want to do now is get into, or do later, is get into the algebra that is behind determining, without using a full-blown amortization schedule, to basically drive to our components of our payment, the rate, the term, and the principal. There's time-proven formulae for this, the time value of money formulae that about 30 years ago when I was in undergrad I had to commit to memory. But I'm going to do an illustration of that next. So thank you for your attention, and I hope this cleared up the concept of amortization of debt.